Hello everyone, how is going? I hope everyone you stay at home. It's very peaceful, and I do hope all your family is very safe during this difficult period. I hope I can meet you very quick again after April 12th. Now we need to continue our teaching. I hope everything will be well after 12th April. Now I just review some important idea I have teach you before. Now, how does the strength comes? As I already told you before, we can look actually for the microstructure of steel. We have the cubic system. So now we will discuss how is the coming of the strength. Firstly, we need to know the microstructure of steel. And now we will look the video first, and you will know what happened inside the steel. This is a
The simple cubic lattice is the simplest lattice structure and
inside the steel, every cubic they have a steel element. So the white color is a steel element.
consists of 8 atoms at the 8 corners of a cube. In the ball and stick model shown here, the distances between the atoms are greatly exaggerated. In actuality,
why is a cubic? Because the length x direction and the y direction and the z direction is all the same. So we call it a cubic structure.
the atoms are packed much more closely together and touch somewhere in the structure. A more realistic model of this structure is the
Actually, this is the core of the atom, but the area is surrounded by the electrons. So the real dimension of the atoms is look like this, including the core and also the electronics.
space-filling model. Here the size of the atoms is in correct proportion to the cell. This space-filling model demonstrates that in the case of the simple cubic lattice, the atoms touch along the edge of the cell. In the model shown here, each atom touches 3 others along the 3 edges of the cell. We can generate the unit cell of the simple cubic lattice by including only those portions of the atoms that appear inside the cell boundaries. In the case of the simple cubic cell, each atom lies 1/8 inside the cell. Since there are 8 of these fractional atoms, there is the equivalent of
the formulation here is actually the corner atoms only head of 1x. So totally we have 8 atoms. So the real occupied atoms is 1 from summation of all the space of the atoms.
1 atom inside the unit cell.
Now, why we need to discuss about the body center? Because during the room temperature of the steel, actually the steel is stay at body center cubic status is in room temperature of steel.
The body-centered cubic lattice contains the same 8 vertex atoms as the simple cubic lattice, but with one body atom in the center of the cell. This simple change results in a structure that is completely different from the simple cubic lattice. Due to the atom at the center of the cell, the vertex atoms no longer touch along an edge of the cell.
Yeah. You may look the space during the room temperature. Here is not enough space for carbons. That means here, okay, you may find here. Okay, let's again.
This gives the equivalent of 2 atoms inside the cell.
Another status is a face center. Face centers is
The face-centered cubic lattice contains the same.
You can look, is a different. The face center it looks like this, and this is body center. So during the high temperature, it is in the status of FCC structure, face center. So you can look the space here is more space. So the carbon atoms could be exist here.
8 vertex atoms as in the simple cubic and body-centered cubic lattices, but also contains 6 atoms located in the 6 faces of the cell. In a space-filling model of the face-centered
You may look during the high temperature.
cubic unit cell.
Here is more space, so the carbon atoms could be exist here. So during the cooling process, the atoms of carbon atoms here and cooling to room temperature, there no more space for carbon atoms. So the carbon should be go outside to form 7 type. Will go outside to form 7 type. That is why we need to say the carbide form. You may look here. The idea is we can again. Sorry. For example, please follow me to write down the VCC structure. Actually, we call this is a FCC structure. You may use a red color. Okay, we use another color like this. Yeah. And the atoms here, sorry, we use the color like this. The red color is a ion. This is ion. And during the FCC state, and we say it's a high temperature. Okay. And in this case, there should be some, because more space, so the atoms of carbon atoms should be exist here. So this is a carbon atoms here. So we can say in this state, more space. More space. But when it's cooling down, then when it's cooling down, should be the space should be become small due to the atoms rearrangement. And the same, the steel also here. But is already changed to BCC structure. We get body center. And here is room temperature. So the atoms should be go outside. The carbon atoms should be go outside from here. Because less space. Because less space. And how about where go? How about next? When the carbon release from BCC structure, and the carbon should be combined with the ion element and become, we say, is a carbide. And this very hot. And how to appear of the carbide? This is the grain of the steel. Actually, we know originally this is gamma. Please follow me to write down on your paper. Follow me to write down on your paper. Originally, is a gamma in high temperature. But when cooling down, should be some is a called a ferrite. So ferrite appear in room temperature. So in this case, should be the carbon will go outside. Carbon will go outside. say the carbon will go outside from the BCC structure. Actually, is your gamma is a FCC, and the ferrite is a BCC. So the carbon released from the BCC structure and will appear here. Appear at the grain boundary. So we call this kind of structure as perlite. So actually, perlite is a ferrite and a plus cementite. Okay, now I will summarize for this for you. You can write down as this. We say it's a grain boundary. And as we say, it's originally it's a gamma area here. Sorry, it's a gamma of the base. But after cooling down, yeah, some of the ferrite appear. Maybe I think it's better to use this color is better. I change to this color. So sorry. I change to this color, better for explain. You see, it's the formation of ferrite due to room temperature when cooling down. And you will see the carbon go outside. From the carbon will go outside here. And there will form another new material like this here. Carbon. So this area we call carbon combined with ion form Fe3C. So we carbide here. Also we say cementite. So that means the full structure here so the full structure here is a ferrite combined with cementite. We call this kind of microstructure is a perlite. it's a perlite. So we say the perlite is the origin of the strength of steel. Be careful. I do hope you can write down, follow me, and you can learn more. We will check your paper. If you write down the teaching content. Or not. Please write down by yourself. Thank you.